So this is the new contents of the unit number 3 in software engineering. So I forgot to put the unit number 3 to write. So coupling and cohesion. So this is one of the content in unit number 3. Now what is the coupling and cohesion? Whenever we are going to design the software, then for the good design, okay, it will depend on the quality of the software, and quality of the software we will design on the behalf of the involvement of the coupling and cohesion. Okay, so if the design is good, it means we will get the better quality software. So what are the different characteristics of good design? Then for the good design, component independence. Okay, it means whenever we are going to divide our program, or we can say the software, we divide into number of modules. You are already aware by this. We divide whole work into number of modules, and each module contains a number of elements in it. Okay, or we can call it as the components. Okay, so a module consists of number of components, okay, or elements in it. And a software, whenever we are going to design, then we will break into number of modules. Then how we are going to connect all those modules, okay, even though each module consists of a number of elements or the components. Okay, so component independence means there is no connectivity, no relationship among various components. Okay, means here high cohesion, low coupling. Okay, if the components are independent, okay, then it means, it shows, it indicates that high cohesion and low coupling. So how the elements are connected to each other, or what are the relationship among various components inside the module, then we indicates its strength with the help of the cohesion and coupling. Okay, so it provides, it develop the relationship, and it coupling, it shows the interconnectivity of different modules to each other. Okay, so coupling is going to connect your different modules. Okay, so that is called the coupling. Cohesion means the interdependency among the elements or the components in a module. Okay, so that is called the cohesion. So this is the first characteristics for the good design, that the component independence. Second is exception identification and handling. Third is fault prevention and fault tolerance. Okay, so for the good design, we will take care of all these things. That is, there must be independence between the components, exception identification and handling, fault prevention and fault tolerance. Okay, so now we will start to understand what is the coupling. Okay, now here you can see degree of dependence among components. Okay, now come to this side. Here, this is a module. Okay, this is a module, and it consists of number of, here you can see the components. So this is component, this is component, this is again. So there are 4 components, for example, just we are considering here. And whenever we will combine these components, then it is called the module. Okay, so this module consists of 4 components. Now we can see how they have the connectivity or interdependency. So interdependency means there is no interface between, or we can say among these components. Okay, no connectivity, no arrowhead, no connectivity with the help of the arrows. Okay, now we can say no dependencies because no connectivity, no networking, nothing else. So this module consists of 4 components but no dependencies. Okay, now what we are going to do, just we are checking the degree of dependence among the components. Okay, degree of dependence means how they are connected to each other. Okay, how the various components are connected to each other. Okay, so that we can calculate the strength of each here component of by checking the connectivity. So it is a sort of networking, we can say. Now come to this side, no dependencies, no connectivity here, no dependencies. Okay, it means we can say no coupling here. Okay, zero dependency means lowest coupling because the strength of the coupling here 0. Now come to this side, loosely coupled, some dependencies. Now here you can check. Again, there are 4 components in a module. Okay, whenever we are going to combine these components, then it is called the here module. Okay, so this is again a module, and this module consists of 4 components, and you can see here this has interface, the data here and the control may flow to each other. Here the direction is one side, again to each other, again here the direction is one side. So such type of coupling we can call as loosely coupled. Okay, now in this diagram you can see highly coupled many dependencies, because here you can see the now you can count the dependencies level here, how the data is going to and fro. Okay, through various channels here. Now you can see, okay, more networking to each other. The data is going to and fro. Okay, the control you can check here. So more arrows, more connectivity, more dependencies. So this is powerful, we can say coupling. Okay, highly coupled, many dependencies. So this is called the degree of dependence among components. So here the degree is very high. So that is called the highly coupled. This is the degree is somewhere lies in midway. That is the loosely coupled. And here no connectivity, no dependencies. Okay. So here the degree is 0. No coupling. Now here we can see high coupling makes modifying parts of the system difficult. Okay, for example, modifying a component affects all the component to which component is connected. Now what is they are saying here, high coupling makes modifying part system difficult. Now just consider this example only, because here various components are connected to each other. Okay, and now you can see highly coupled many dependencies. Now whenever we are going to upgrade here the portion of this component, now this will affect all these 3 components. Suppose we are going to update here, then this has the very strong dependencies on these 3. Okay, so the modification is very difficult in this case. Okay, even though here if we want to update our program, update the software, then here easy. Okay, because these are the loosely coupled, this may affect all these components, but it is easy as compared to, but in this case no connectivity here. Now we can easily modify our program. Okay, this component will not affect all remaining these components because no dependencies. So this is the difference, how we are going to calculate the degree of dependence among the components. Okay, so if it is highly coupled, then it is very difficult to modify the part of the system. Okay, modify to different components. If it is loosely coupled, then it is easy to update, and in case of no dependencies, then we can easily update those or modify. Now here we can see the coupling. So this is the here we can say the order in which just we are showing or indicating in order from good to bad, good to bad coupling. So this is the just we are going to check the strength of the coupling. So data coupling, if we are using this, then just we are going to check the strength in order. So this is called the good. So we are using the data. These are the types of the coupling. Either we can use the data coupling, stamp coupling, control coupling, common coupling, content coupling. Okay. So if here you can see data coupling, it means here the order is good, means more powerful, more strength. Okay, as we will go downward, then the content coupling. So at the lowest level, we can also called as bad. Okay, so the strength of the coupling here is bad. The level is bad. Okay. So data coupling, it is more powerful. After that, stem coupling. After that, control coupling. And at the lowest level, you can check here content coupling. So these are the various classification or the types of the coupling. Coupling means you have already understand that the interdependencies of various components in a module. Okay. And there are number of modules in a software. Whenever we are going to design any project, so we divide our project into number of modules, and each module consists of a various number of components, and how those various components are connected to each other, or we can say highly coupled, loosely coupled, or no dependencies. You have already seen. Now this is called the range of coupling. So this is range. Now in this diagram you can see again these are the various types of coupling: content, common, control, stamp, data, uncoupled. So again, if we will check the order, or we can here arrange in the order. Now you can see, so this is the lowest order here. Coupling means low connectivity, means no connectivity. Okay, in case of the, if there are various component and no interdependencies, okay, no connectivity, no networking, then we can also call as uncoupled. Okay, this is uncoupled. Uncoupled means no connectivity among the components. Okay, so this is called the low, yani ki here the strength is very low. And as we will approach towards, okay, at the top side, then in the center we can call as the loose, okay, or loosely coupled. The coupling is at the here at the midway, or we can call it as the loose coupling. Okay, loose coupling means some components are connected to each other. It is all right, but the dependencies is at the midway. Okay, so not so much connectivity as in case of the highly coupled components. So this come, we can say, as we will approach at the top side, data, stamp, control, up to stamp, this will come under the loose coupled, and then high coupling as we will proceed further toward the top side. Then control, common, content, this is highly coupled. Okay, highly coupled means inside this inside the module various components have strong connectivity or the networking with each other. Okay, so in this way we can check the range of the coupling. Okay, how the components are connected to each other. Now, what is the control content coupling? Okay, now we can define the various types or the classification of the coupling. What is this? Now you can see here, content coupling is what? One component references contents of the another. It means here we can see the connectivity. One component, okay, references contents of another, means strong connectivity. So without each other, we cannot use the term this content coupling. It means interdependencies, okay, among all the components. So one component here will give the reference for the other, for the other contents of the, for another one. Now here the various we can call as the various examples. Component directly modifies another data. Okay, so if there are suppose your module contains 4 or 5 components or more, then with the help of only one component, we can modify the data of another. Okay, it means interdependencies among the components is very strong networking among the components. Okay, so component directly modifies another data. We can easily modify the data of another component. Okay, so component we can here called as the small programs or the procedures. Okay, or we can call the functions, because a program contains a number of functions, and we check each functions whether it is working properly or not. Then we these various procedure, or we can called various parts of the program, these are called the components. So with the help of one component, just we are going to modify the data of another. So this comes under the content coupling. A component refers to local data of another component in terms of numerical displacement. Component modify another's code, e.g. jumps into the middle of a routine. Okay, it means interdependency is more here. With the help of uh, any component, just we are going to change or update or modify the code or the data of another component. Okay, so here interdependencies is more powerful. So this is called the content coupling. Just we are changing the data of another on the behalf of other component. Okay, so this is called the content coupling. Now the examples here, part of the program here handles lookup for customer. When customer not found, component adds customer by directly modifying the contents of the data structure containing customer data. So each component have here the data structure. Then the with the help of the data structure, we can change the data of another component. Okay, so it is a sort of we can call part of a program. Okay, so part of a program handles lookup for customer. So if the customer or the user want to change the data or the program, we can say, of another component, then we can easily add some new we can say the functions to that, or we can update or modify. Okay, so this is one of the example of the content coupling. Another here we can see part of the program handle lookup for customer when customer not found. If there is a no existence of the we can call the customer, then component adds customer by directly modifying the contents of the data structure containing customer. So with the help of another component, we can change or update the data. Okay, so in this way we can change the data of any component with the help of the another component. So interdependency is more powerful here. So now what type of improvement we are doing when customer not found? Suppose if there is a customer here, means there are 4 components, and if one is not found, then component calls the add customer method that is responsible for maintaining customer data, so that another component can maintain the data of other component here, or we can say other customer data. So just we are here treating the component as a customer data. Okay, so we can change the customer data with the help of another components. So this is another example for the content coupling. Now another type of coupling is called the common coupling. So what is the common coupling here? Two components share data. Okay, so in this case, only two components can share data to each other. Okay, so what type of data here? Now you can see global data structures, common blocks. Okay, so because each program consists of a number of blocks, that is called the common blocks, and also the global data structure. So there are various terminology or various variables, so we can called as the global variables, or those variables consist of a reside in a data structure, that is called the global data structure. So in this case, common coupling means there are two components share data, okay, with the help of the global data structure or common blocks. Now you can see here usually a poor design choice, because here we can call a poor design. Okay, good design and another is the poor design. So usually what we are doing, a poor design choice because lack of clear responsibility for the data. So here the responsibility is less, or we can call it as the lack of clear responsibility for the data reduces readability. Here there is a lack of the, we can call each program consists of the data, okay, and also the various we can call the documentation here. So reduces readability here. The if we are using the common coupling and there are two components, then in this case the readability is less. Okay, so lack of readability here due to the poor design. So here the design which is done by the programmer is not good. Okay, difficult to determine all the components. Here we are unable to determine all the components that affect a data element. Okay, we are not aware which components are affecting the data of another component. Okay, difficult to determine all the components that affect a data element. Okay, so that we cannot maintain it, reduces maintainability. Now difficult to reuse component, here we cannot reuse component. In case of the content coupling, we can reuse all those components, okay, due to the high coupling, or we can say the interdependencies. Now in this case we are using two components, they are sharing the data, okay. So in this case difficult to reuse component, we cannot use again and again the component. Here reduces ability to control data accesses. So here just there is a reduction, okay, because interdependency is less in this case. So we can call here there is a reduction in the ability to control data accesses. We cannot access the data of each component with the help of another component, okay, as we have seen in the preceding case, because here interdependency is less or less powerful. Now these are the again example for this type of coupling here. Okay, so process control component maintains current data. Here just we are going to maintain the only the current data about a state of operation. So gets data from multiple sources. Here we are getting the data from the multiple sources, supplies data to multiple things. Okay, each source process writes directly to global data store. Each sync process reads directly from global data store. So here due to the less power, or we can say the reduce or reduction or less strength of the coupling, here the interdependency is less. Okay, so due to this less power, here each source process writes directly to global data store because interdependency is less. So each component will work according to his own rules and regulations. Okay. Now here we can see again the another here example. The data manager component is responsible for data in data store. Okay. Here again there is a role of the what type of improvement we can do. So it is managed by the data manager. So data manager component is responsible for data in data store. Now here the component is responsible for the data in data store, but the difference between these two is here the strength is less, but in case of the content coupling, the networking is more. So the interdependencies power is more as compared to this. Okay. So processes send data to and request data from data manager. So here we use another source. So with the help of the data manager, the component retrieve the data from the components. Okay, to each other, but with the help of the data controlled by the data manager. Now here we can again here check control coupling. So what is the control coupling? Component passes control. So here this is very simple. Here the control is passing. Okay, component passes control parameters to coupled components. Okay, so here the control, the component is passing the control. Okay, so that we want to again increase the strength. So how the components are going to coupled again. So the control is passes with the help of the components to each other. So maybe either good or bad. So we are not aware about the strength, maybe either good or bad, okay, depending on the situation. So what type of situation we are facing that time, then it will depend on that, okay. So uh, instantly we cannot measure the strength, but it will depend on the situation, okay. The bad when component must be aware by the internal structure and logic of another module, because each module consists of a number of components. So how we can differentiate whether it is bad or good? So in case of the bad, when component must be aware of internal structure. If the components, if they are aware by the internal structure and logic of another module, if there are various modules, then how they are connected to each other, various module, and after that, when it is called the bed, when component must be aware of internal structure and logic of another module. Okay, good if parameters allow factoring and reuse of functionality. So good if we are able to use the advantages of another component, then it is called the good, or we can avail or we can use those parameters of the each component to each other, then it is called the good. And if we are unable to do this, then it is called the bad. So this is called the control is good or bad. It will depend on the situation. Okay. So this is one of the example for that, acceptable or not acceptable. Module, here P calls module Q and Q passes back flag that says it cannot complete the task. Then Q is passing data. So this is the situation, okay, during the programming. So it will depend on the circumstances of the programming, how the modules, they are passing the data to each other, or the calls to each other, what type of data we are going to call. Then if it is it is happening like this, then we can say acceptable, otherwise not acceptable. When what module P calls module Q and Q passes back flag that says it cannot complete the task. Okay. Here, and as a result, write a specific message. But in this case, here there is no any such type of the data is passing, but we are not going to write any message. So here in this case, write a specific message as a result, then we can say it is not acceptable. Okay. If we are getting any sort of specific message, okay, regarding about the calls, then we can called as not acceptable, or otherwise it is called the acceptable. So it will depend on the uh, programming, or what type of programming we are using and what type of calls we are using there. Now it's time coupling. In this case, you can see component passes a data structure to another component that does not have access to the entire structure. Okay, so the data is passing, but we cannot access here to the entire structure. So there are another component we are using in the same module, but with the help of other component, we cannot access the data of all components with the help of one. Okay, so we cannot access the entire here the data by each one component. So if we are going to update the data of one component, but here we cannot do, or we cannot access the data, okay, or we cannot access the entire structure if there are suppose 4 component in a module, but we are not uh, to do, because we are using here some sort of rules, but we cannot access the entire structure here. So this is sort of called the stamp coupling. Stamp coupling means we are doing the work, but for a special case only there. So regards a second component to know how to manipulate the data. So in this case, we will take the help from the another new component. Okay. So with the help of the data structure, because each component have its own data structure, then require second component to know how to manipulate the data. Okay, if there is a need arise to update the data of one component, then we take the help from the data structure of that particular. So maybe necessary due to efficiency factors. This is a choice made by insightful designer, not lazy programmer. So the here the everything will depend on the programmer. So because he will design, he will do the designing, whether it is a good or bad. Okay. So the quality we can identify with the on the behalf of the design. Okay. So if it is good design, then we can say better quality, good quality, and it is also depend on the skill of the programmer. Suppose if we are going to design any project, and if the programmer have less experience, then he will write the project, and he may involve a number of lines, okay, to do the particular task. And another we can say programmer, he is also achieving the same goal but in less number of lines. So it will also depend on the skill of the programmer and the past experience of the programmer. So the designer must have good experience, because he may design good or bad. Okay, so that will affect all the rest factors. So whether it is a coupling or cohesion, how we are going to interconnect all these modules, or how we are going to interconnect all those components. So this is the difference between the coupling and cohesion. Now this is the example related to the stamp coupling. Okay, the print routine of the customer billing accept a customer data structure as an argument. Here, this parses or divided and prints the name, address, and billing information. For customer billing system, it is one of the example. Here, now we can say component passes a data structure to another component that does not have access to the entire structure. Okay, here we cannot uh, take the advantage of the whole structure by using the help of only one component. So this is called the stamp coupling, and this is one of the customer billing system comes under the example of the stamp coupling here. Now another how we are going to improve this method. So just they are mentioning here. Now the another type of here coupling. Now you can see, so two components are data coupled if there are homogeneous data items. Now it will depend upon heterogeneous or homogeneous. So the type of the function may be same. Okay. So what is the data coupling? If two components are data coupled, if there are homogeneous data items, means the category or the nature of the function must be same. Okay. Or the type of the component must be same. So here now you can see every argument is simple argument or data structure in which all elements are used. Now good, if it can be achieved, then it is called the good. Easy to write contract for this. Now here the modification, now you can see, is independently we can here work. Okay. So for the data coupling, here two components are data coupled if there are homogeneous data items. So here the nature must be same. Now the key idea in object oriented programming design tend to have a low coupling. So in case of the OOD, whenever we use the OOD here, object oriented design, okay, so tend to have low coupling. So here in this case, if we are using the concept of the object oriented programming, so the strength here of the coupling is low. Okay. So during the design, this is the key idea, that is the background about the object oriented programming, because these all are based on the classes and the objects, and each class consists of a number of objects here, and how they have the connectivity. So in this case, if we are using the object oriented programming, then here the strength is less, that is called the low coupling. Okay, among various functions. Okay, among various objects in a class. So class here will act as a module. Okay, and inside a class, so there are number of objects we can say, then that will act as a component, and how they have the interconnectivity to each other, then we can here indicate whether it has the low coupling or uh, powerful coupling, that is high coupling. So this is the basic idea that here the coupling is low. So object oriented design always have the low coupling. Now what is the, here we can call the cohesion. Now coupling you have already seen the interdependability among the various components. But what is the cohesion here? The degree to which all elements of a component. Now here we will talk, because each component consists of a here number of elements here. So the degree to which all components of a here elements of a component are directed towards a single task, and all elements directed towards that task are contained in a single component. Okay, so the how the various elements have the interconnectivity. So here we will check under the cohesion. So internal glue with which component is constructed. Okay, all elements of a component are directed toward and essential for performing the same task. High is good. Okay, so whenever the strength is high, then we will tell the design is good. So cohesion here, a module consists of various component and component consists of a various element. So then how the elements they have the interconnectivity, how they are connected to each other. Okay, all elements of the components are directed towards and essential for performing the same task. Okay, if they are performing the same task, all elements, then this shows or indicates the cohesion. Now I am going to take your attendance again of this period. Now please, a few seconds are left. If there is any question, please tell me.